All right, so I'm gonna let you do this one on Zoom, but I wanted to do kind of a different one just to give you a clue of what non-isomorphic means without having to match all the vertices. So let me just do a different one. So what if I said not simple, so graph with 3 vertices. Okay, I guess I don't need a line, but okay, so you're going to do this. I'm going to do this. Okay, so not simple graph with 3 vertices. Okay, so it's not telling me how many edges. So not simple. Remember, simple means no loops or parallel edges. So let me just begin. It's going to be really long. So here we go. So that's a graph with 3 vertices, right? This would be another graph with 3 vertices. This would be another graph with 3 vertices, right? So there's one. Let me just put lines between them, right? So there's 1, 2, 3. Okay. Whoops, and that's just a vertex. So here we go. So here's another one, right? So all these 4 are not isomorphic. So be careful. So if you drew this one and put a loop here and a loop here, these 2, right, this one here and this one here are the same graph. They're just drawn differently, but they're isomorphic, correct? Because we've got 1 isolated vertex and 2 vertices with loops. So these would be the same. So non-isomorphic means be able to like move them around and notice that they are truly different. Okay, so let's try some others. So what if, oops, I didn't mean to necessarily change to red, but I guess it doesn't really matter. Okay, so here I'm going to start with just edges, right? So there's 1 edge. So let me just go back to blue. Okay, so I'm just going to kind of try to show you how, I'm going to say here's 2 edges, right? Like that. And so another one that would be not isomorphic would be 3 edges, right? Okay, so we could have 3 edges and it could look like, since it didn't say necessarily simple, it could look like that. I could have parallel, right? Or I could have 3 edges and 1, 2, 3. Kind of crazy looking, right? So lots of different kinds of graphs, right? So then you could do the, have all of them here and then have an extra loop here. So this is not isomorphic with any of the others. So non-isomorphic means you shouldn't be able to, match it up, spin it around, and see that it is the same graph. So that's what you get to draw here. And I'm out here no more than 2 edges, so that limits the number of them. 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 here just to help you. There's only 4 here. Just to know, so that you know when you're done. 2, 3, 4, 5, 6. This one, there's 12. Ooh. Okay, so this one here, this one, I have 19 of them. So non-isomorphic graphs with 4 vertices, and I'm limiting it to 3 edges. So, oh, that's what I started doing for you already, didn't I? Kind of. Limiting it with 3 edges and 4, no, this one had 3 vertices. Okay, so this one's got a lot of them because there's so many variabilities, right? So I'll just let you practice and see if you can find them all. I will not give you one on the test that has 19 to find, but it's good exercise for you to see all the different variations that can happen.